Today we want to discuss about the Riemann sum. Choose for each n a partition of the interval AB into n subintervals such that maximum of delta xi in the nth partition approaches 0 as n approaches to infinity. If Ci is the point chosen in the interval xi minus 1 to xi, then limit as n approaches to infinity of summation I varies from 1 to n f of Ci delta xi is equal to the integral of fx from a to b. This is called the Riemann sum. The interval given, in other words, we see that the lower limit is a, upper limit is b. So therefore our main interval is AB. We divide this interval into n subintervals such that the maximum of delta xi in the nth partition approaches 0 as n approaches to infinity. If n approaches to infinity and Ci is a point chosen in the interval mentioned here xi minus 1 xi, then this limiting value is equal to the integral of fx from a to b. Let us discuss an example to further describe it. We want to write this integral x cube from 0 to 1 as a limit of sums. We divide this main interval 0 to 1 into n equal parts by partitioning this interval. Definitely it will be first point will be 0 and the last point will be 1 and n equal parts, then our next point will be 1 by n and so on, 2 by n, 3 by n, 4 by n, and at the end n by n. Select Ci, which is I by n, because here we see that I varies the right endpoint of the interval I minus 1 by n to I n. If we select ith interval, then our Ci will be I by n, the right endpoint of the interval. We have the interval subintervals as 0 to 1 by n, and next interval is 1 by n to 2 by n, and next interval is 2 by n to 3 by n. This is our first subinterval, this is second subinterval, this is third subinterval, and we can imagine that in our ith subinterval we will have the right endpoint I by n, which is selected as Ci. This is the Ci. According to the definition of Riemann sum, let us continue. We have selected Ci and our function is x cube. X cube is our function, and Riemann sum of is equal to summation Sn is equal to summation from where I varies from 1 to n of f of Ci delta xi. Ci is selected, delta x is equal to delta xi. And this will be equal to Ci cube because we have this value f of x as x cube. We can write that f of Ci will be equal to Ci cube, and our each in width width of each interval is 1 by n. So the width of ith interval will be also equal to 1 by n. Therefore, we can write as, and again Ci is equal to I by n as we have calculated in the last step, and this will be the sum, and combining we obtain this sum. According to the definition, we will write it as limit n approaches to infinity, sum of I cube by n4. We can take 1 by n4 outside of the summation because I has to vary. Therefore, here we write only summation of I cube. Then according to the definition of Riemann sum, this integral is equal to this limiting value. Thus we can find this interval if we can evaluate the limit or vice versa. Hope you will have to understand. Thank you.